Hello everyone and welcome back. My name is Puriya and finally in this video I'm gonna show you some exciting stuff. We are gonna use our Juniper examples to apply the configuration on our routers. So without any further ado, let's jump into it. Okay, let's continue where we left off. So if you remember, in the previous video we just installed Inmanta and we got into this page, which is called the web console. The first thing that we have to do here is to create a new environment. Think of environment as a means to provide segregation between different parts of your network or even different projects. For example, to put it simply, let's say you're having a test environment and a production environment. Obviously, you want them to be separated, and if something goes wrong in the test environment, you don't want it to be propagated into the production one. All right, let's go ahead and create a new environment. I'm gonna name it examples. Juniper. You can provide a description, a repository, and a branch. Repository and a branch are not really relevant to what I'm showcasing in this video series, so I'm gonna skip over them. Oh, and by the way, you can also provide your icons. Let's click on submit. The environment is created. Let's go inside of it. And there we are. There is nothing much going on at the moment, but soon it will be fireworks. So I need something here, and that is the environment ID. You can get it in two ways, either from the URL here. I hope the font is big enough for you to see, or we can click on the settings icon here, go all the way down, and then we can copy the environment ID. Let's copy it and go back to my terminal. Before going to the terminal and start deploying the configuration, I would like to discuss a few points. So in my text editor, I have remotely connected to my virtual machine, as you can see here. Puriya from the future here. While editing, I noticed I didn't show you how to remotely connect to a host within your VSCode. So let's quickly go over it. Here at the bottom left corner, there's an icon. If you click on it, we have to choose connect to host. Then you can provide the host name and the username and the IP address of that machine. I have some sets of configuration on my local machine which allows me to omit providing a username, but your case might differ. My IP address is this one. Let's connect to it. Or no, actually it's this one. And there we go. We have access to that machine. So I can go to examples and networking, Juniper, click OK. And I get everything. Back to the video. I have opened the Juniper folder. Let's say I want to apply the interface configuration to Juniper. Let's first open it up and see what's inside. I don't know about you, but it's kind of difficult for me to read all this white text. But worry not. Let's install the Inmanta extension. Let's go to the extensions here, type Inmanta, install. Perfect. Let's go back to the interface example. Much better. Let's also do this. All right. Every line is commented, so you know what to change, where to look if you want to modify something, and also to give you some confidence to kind of alter this model. I'll go over it very briefly. On top we can see we are importing the Juniper module. Then we are having some variables containing the router name. This host name, which is equivalent to router, is gonna be the agent name. Later on, when we deploy the model, I'm gonna show you in the web console how things look like. Management IP, the netconf port, username, password. Then we are putting all of this in the device. We are instantiating a device here and feeding this all of the information. Next, we are tinkering with two interfaces, Gigabit Ethernet 1 and 2. For Gigabit Ethernet 1, we are giving it a description, very creative, and we are assigning an IP address to it. Then on Gigabit Ethernet 2, we are changing the speed and MTU. All right, now let's go back to the terminal and see how we can work with this. Okay, now that we are back to the terminal, let's see how we can apply this configuration change to our router. But before that, let's see if the model that I have written is semantically correct. How do we check that? We can use Inmanta tag vvv compile tag f interface. So if you don't know, these V's here increase the verbosity level. I would like to get as much information as possible, but not too much. All right, this is gonna fail, and we will see why. We are missing the Juniper module. How do we get it? Let me go back to my code editor. The secret lies here in this file, project.yaml. Whenever you try to compile or export a model to the server, the compiler checks the local disk for the module. If it's not already present, it will go ahead and uses this project.yaml file and looks for those repositories you put here and downloads that module. Juniper is not open source or free, but if we quickly go to this link here, you can see the open source modules we have. For example, VIOS, which is also free. You can download VIOS in a virtual machine and use our models to interact with it. I don't want to steal the spotlight from Juniper in this video, but if we just quickly get this over, let's get the raw, copy it over. Inmanta. You can see how everything is put together. All right. Now I need to add the repository which is containing the Juniper module here. For that, let me bring my token here and paste it. Save. Now let me explain something here. Whenever you license a module from us, you'll receive a token similar to this one. You place it in your project.yaml file, save it, and then you can have access to that module and use it freely. Now let's get back to my terminal. All right, Inmanta, let's first install the project. Project install as instructed on this line here. Let's check the directory. You see this libs folder now is created here, and it's being populated by the modules that Juniper requires to operate properly. Okay, let's see if it's done. Yes, now let's compile. Compilation done. No semantic errors in the model that we've written here. All right, now let's go ahead and actually deploy it on the device. How do we do that? If you remember, we have to first compile this model and send it to the server. Then the server will spin up the agents, and those agents will go ahead and apply the configuration on our router A. The command for that is Inmanta tag v export tag f interface. Enter. Oh, sorry, I have to also provide the environment ID we copied over. Do I still have it in my clipboard? Nope. Let me quickly get it. Okay. And done. Let's go back to the web console. Now let's click on desired state. Then on details. Here we can see two resources. The first one is related to the agent we require. And hey, this is the name I just referred in the code, router. And we are having a Yang resource, which is depending on this agent. Let's open up the Yang resource. Here we can see all the information about that Yang resource. Most importantly, if we go all the way down here on the XML part, let me just expand it. We can see the desired configuration that we would like to sit on the device. Let me copy it to my code editor. I guess it's easier to read like that. Okay. We can see Gigabit Ethernet 1. The description is being changed. We are setting an IP address on it. For Gigabit Ethernet 2, we are changing the speed and MTU. Now let's go back to the web console. Go to resources. We can see the deployment is in process. Now, if it's the first time that you are applying this configuration on a device, it's going to take a while, and the reason for that is it's going to download all the Yang supported models from the device. Let's give it some time, and when it's done, I'm going to come back and explain a few things. Then we are going to apply another configuration. Now that the deployment is complete, let's go to the router and check the configuration. Okay, let me clear the screen. SSH router A. Okay, show configuration. And here we go. We are having our description, IP address, and on Ethernet 2, speed and MTU. Now let me exit from this mode. What if I want to change something on interface Gigabit Ethernet 3? Let's go back to our model here. Okay, if you remember, we are having interface 1 and interface 2. Let's say I want to apply an IP address on interface Gigabit Ethernet 3. What do I do? It's not too complicated. I'll just borrow this text from here, copy it, go to the end of my file, paste it in, and we just change these names. We don't want to have any duplicates, so I just change it to this. I'm still using the same device. Now I want to work with Gigabit Ethernet 3. For description, I say G3, very descriptive. Units, we need to change this as well. Unit 3, interface 3, family inet 3, unit 3. And for the address, let's also change this and this. All right, let's go with 172.18.18.1. /24, save the file, go back to my terminal and redeploy it. Okay, now let's jump back to the web console. We are deploying, and once it's done, I'm going to show you some logs. Okay, now the deployment is done. Let's click on Yang resource details. Let me first show you something. If we go to the history tab, we can see a history of the configs that we have changed. For example, this is the initial one we have pushed. If we open it, we go all the way down, expand this section. We can see we set this IP address on Gigabit Ethernet 1 with this description. And these are the changes we did on Gigabit Ethernet 2. On the next version, let me just close this here, expand the other one, go all the way down, expand it. Now we can see Gigabit Ethernet 3 is also there, and we have set this IP address on it. So this is a very good and comprehensive view that can show you what has changed during a time frame. Let's also go to the log section. I'm gonna make it more specific. We push it at 11:30. Okay. $34. Let's apply it. Let's also change the orderings. So let's see what happened here. We started the run for this resource Yang. We are about to deploy it. We get the username and password. We create a Yang session or netconf session to the router we have. We load the modules we need. In this case, you see Juno's conf root, and there should be more. Then we are also loading the interfaces model. Now let's go to the next page. Okay. We get the current device configuration here. You can see it has Gigabit Ethernet 1 and 2. There is no Gigabit Ethernet 3 yet. Now we are calculating the differences between the desired state and the current configuration. So if we open it up, we should see Gigabit Ethernet 3 there as well. There we go. Now we should go ahead and apply this. So we got the differences. The result is non-empty. The configuration is applied, and now we are closing the Yang session. Next, we should see end run. So the deployment was successful. Let's also go back to the router and check it. Clear the screen. SSH. Show configuration. And voila. Now let me also show you one more thing. What if someone goes ahead and changes something here? Let's say, first, let me pause the Inmanta server. And this is how you do it. You go to the web console, click on this stop button. It will halt all the operation of Inmanta server. So we are not going to apply anything to the router anymore. I want to make a change, let's say by mistake. Then we are going to see how Inmanta is going to help to repair it. Let's click on stop. Yes. Go back to my terminal. Let's say we are using this interface here as an underlay for our other encapsulation protocols. It could be IPsec, EVPN, what have you. Another network engineer who doesn't know about this comes, checks the configuration, and goes like, oh boy, I've only seen this to be 1500. This is not right. Let me fix it. So he does us a favor and fixes it for us.
Let's go to configure, set interface to MTU 1500. Commit, exit, show configuration. Okay, now for those who have dealt with these MTUs in the past, they know how difficult it is to troubleshoot these things. How can Inmanta help us to recover and repair this? Alright, let's go back to the web console. Up here on the top right, I'm going to click on settings, go to configuration tab. I need to change two values here. By default, Inmanta checks the desired state against your running configuration, and if there is a contrast, Inmanta goes and makes sure that it complies to the desired state. So for demonstration's sake, I'm gonna change this to 30 seconds. Save. Also this one, I don't want to wait much longer. I just change it to 30 seconds as well. Save it. Let's go to resources, click on resume. Yes. So after 30 seconds, Inmanta is going to connect to the router, check its current configuration against the desired configuration, notices this MTU change, and it goes ahead and reverts it back. So let's wait a little bit and then I'll show you what happened. And in the meantime, let me exit from the router. All right. It detected the change. And done. Let's connect back to the router and see the configuration. And here we go. So you can see how much of a headache it saved us. And without any manual intervention, we are having our desired state back. Okay, I don't want to make this video much longer than what it is. Please let us know if you have any questions in the comment section. And feel more than welcome to go ahead and experiment with other examples that we have here. BGP, bridge domains, EVPN, everything is there and commented out. Thanks for watching and see you in the next video.